All right, today what we're going to be talking about specifically is not just similar polygons, but similar triangles. So I'm going to show you guys something real quick. All right, what I'm going to do is I am going to just, you guys don't have to do this, I'm just going to make a couple of parallel lines. So this one goes down 1, 2, 3, 4, 5, and over 4. So right here, I probably need to go a little bit further. Go down 6 and over 4. Down 6 over 4. And here I'm going to go down 3 and over 2. So if I were to say connect from here to here, and from here to here, these triangles would be similar to each other. Okay? So, how would they be similar? I'm going to label this A, I'm going to label this B, I'm going to label this C, D, and E. Now, it's kind of cool because I use how many different colors? 3. So, the thing that's neat is this side right here, okay, will be similar to this side. Okay? And this side right here, E to D, will be similar to A to E. And the distance from C to D, right here, will be similar to A to B. Not congruent, but similar to. So this is a scaled down triangle. Now, what angles do they share that are perfectly in common? This angle right here, right? So this angle right here, AEB, is perfectly equal to CED. So these angles right here are perfectly congruent right there. Do you know what I probably should do? I should probably do the same color as the opposite side. That makes more sense. There we go. We'll use green. Okay. Now, this side right here, this angle right here is going to be similar to this angle, not similar, equal to this angle. And last but not least, angle C. That's right, they're going to be congruent. So there's all of your congruent angles. So these angles right here are congruent to each other. All right? So just like I said, order matters, right? As far as how we set up our triangles. So I'm going to make a similarity statement between these two triangles, and I'm going to make sure I go in a specific order. Okay? So I'm going to start. So how about this? I'm going to start with A. We say triangle A. Then I'm going to go to B, and then travel to E. This triangle is going to be similar to this triangle. But if I'm at A, what color did I make that one? Blue. So I got to go over to the blue angle. So I'm going to go right here and say triangle D. And then where did I travel to here? I went from what? A to B to E. So I went from blue to purple to green. So I have to travel from what? Blue to purple. See it, brother? Their pattern? Blue to purple to green. So we say D to what? C to E. So these are similar, which means I know exactly which sides are now proportional. Well, not congruent, but proportional to each other. Okay? So, you see the colors that we did here? This is what we're going to do on your problem. Let me go back. Take a look on that problem. Take a look at this problem. We're going to help you out. So check this out. What I want you to do, I'm going to not make this so thick. I'm going to choose a color right here. This side right here is proportional to this side. It's amazing that when you're doing recordings, how many people have to sneeze. It's unbelievable. It's all right. Remember, you sneezed earlier. You sneezed. It's okay. It's just like it's gotta sneeze. It's because students in America are allergic to math. That's what it is.
I think it's just everyone in general.
All right. So next thing I'm going to do is I'm going to color this in right here. And I'm just going to keep going the same color. And last but not least, there we go. This might help you when you're trying to set up, like, what's proportional, okay? What, not congruent, but what's proportional. So right now, if we wanted to set this up, to figure out how to solve for x, what are we going to compare? We can compare the green to the blue, and we can also compare the green to the blue. Which number am I not going to use in this problem? The 16. Not going to use it. That's there. That's called extraneous information. Extraneous meaning it's extra stuff that you don't need, that you might use accidentally. So right now, what I'd like you to do in your journal, okay, is I would like you guys to set up LM is going to be proportional to which side over here? L to M is proportional to Q to P, all right? So we go LM to QP. Now, over here on this side, we're going to compare it to L to N. So I'm going to put an L and an N, put a little fraction bar, and I'm going to set this equal to the distance from P to N. So it's important to know what you're going to compare. So right now, at this point, I'm going to substitute everything I have. L to M is x plus 3. L to N is 18. Q to P is x minus 1. And P to N is 12. So at this point, this is your proportion that you're going to be setting up. So let's kind of read over the problem. I'm going to look at yours right here. It says, identify the similar triangles. Okay, so we're going to write a similarity statement. It says, find x and the measures of the indicated sides and explain the two possible scale factors, whether it's an enlargement versus a reduction. Okay, so let's start with our similarity statement. So if I say triangle L to M to N, so if I go from L to M to N, what is that going to be similar to on the right side? So let's think about this. L is across from which side? L is across from the, which is on the red, right? So which side, which angle is across from the red over here? P. So I'm going to start with P. Then what did I travel to? I traveled from L to N. Where's M across from? It's across from the 18. Which side is that's the blue side. So which angle is across from the blue side here? Q. There we go. So there's your similarity statement. Okay. Now let's go ahead and solve for x. So now we have 12 times x plus 3 equals 18 times x minus 1. Put those in parentheses. Now, if you don't like the way this looks, you can also write 18 times x minus 1 equals 12 times x plus 3. Just know that your cross products are equal. These right here, these are the same statements. So, distribute to both. All right, since I set it up like this, I'm going to go ahead and solve it from here. I have 18x minus 18. So this is called the distributive property, where you multiply the 18 to both numbers. So I also have to do it over here, which is 12 times x plus 36. Now, where do you think I put all of my values for x on this side, on this problem? On the left or the right?
The right.
No, but on the left. Why the left? Because I have 18x's over here, and I have 12x's, which I'm thinking ahead. If I have to take away a 12x, I'm going to have to take away 12x over here, and how many x's do I have left? 6. Very good.
If you have a bigger number and if you have a smaller number, you always subtract the number. So you have a small number.
I'm not sure exactly what you're saying, but I'm just going to nod my head and agree.
She was basically saying you don't want to do the 18 minus the 12
because then you have a negative. Yeah. So what I try to do is I try to make sure whatever answers over here is going to be positive. Good job, I appreciate your interpretation. All right, you're now considered a great news interpreter.
Yes.
We're going to add 18 to this side, and we're going to add 18 to this side. So here, this adds to 0. These are additive inverses. Here we get a total of 54. And I saw you over here, Caleb. I saw your work, and I saw you got x. Good job. Because you divided both sides by 6. And on your own, boom, you got 9. And that was correct. All right, good job.
I just had that thing.
And you still got the same answer. All right? So we get x equals 9. So what am I going to do with this 9, everybody? Because that's one of my answers. Number 2, I'm going to put x equals 9. Sorry, Joe, go ahead.
I don't know, I'm guessing.
No. I'm going to take that 9, I'm going to plug it in here. I'm going to take this 9 and plug it in here. So right here, x plus 3 is 12, because 9 plus 3 is 12. And 9 minus 1 is 8. So now, step number 3 and step 4. Step 3 is basically if you can have an enlargement or a reduction. Destiny, which numbers did you compare? Did you compare the 12 to the 18, or did you compare the 8 to the 12? 8 to the 12? So the cool thing is you could have actually also compared the 12 to the 18 and got the same number. You did both? So I'm going to compare 8 to 12, and what does that reduce to? That reduces to 2/3. So what does the 2/3 go with? An enlargement or a reduction? Reduction, because it's what? Less than 1 but greater than 0.
Yes.
And what would be the enlargement if we're comparing 8 to 12? 3/2. So we just did one, basically had the exact same ratio. Okay, exact same enlargement and reduction. And finally, last but not least, it said find what? LM and QP. So LM was a certain distance, and QP was also a certain distance. So our distance from L to M was 12, and the distance from Q to P was 8. This is what I'm expecting to see on your paper, is a box that I can clearly find all of your answers, your similarity statement, solving for x, your enlargement and reduction, scale factors, and the distance from L to M and Q to P.